In the previous videos, you guys learnt about binding energy and how that curve is being plotted. Binding energy per nucleon, isn't it? Now in this video, we'll discuss about nuclear forces. See, one thing, it's a very simple, in layman terms, nuclear forces are what? They hold the force which holds the nucleus together. This is a nuclear force. But you guys have to learn a little more than that. Now, when we talk about nuclear force, remember, it's the force within the nucleus. It is not force outside the nucleus. Okay? It's not about the nucleus proton, the proton in the nucleus and the electron which is revolving. No, this is not what we are talking about. Here, the nuclear force talks about the force between the two nuclear particles, two nucleons you can call it. Okay? There are certain characteristics of nuclear forces which you guys have to know. See, this nuclear force, whatever we have, they are charge independent. In the sense, between two protons, two neutrons, or a proton and neutron, the force of attraction is always the same. Okay, that means nuclear forces are charge independent, or you can say they are independent of charge. This is the first important characteristic of a nuclear force. See, the second one, they are the strongest forces in the nature. You guys have learned this last year, but still, again, let's recap. Second point, they are the strongest forces in the nature. Okay, now, they are so strong, to give you a perception, they are 100 times stronger than electrostatic force and 10 to the power of 38 times stronger than gravitational force. Guys, 10 power 38 times, 1 followed by 38 zeros. They are so strong compared to gravitational force. Okay, so they are the strongest forces in this entire nature, or in this entire universe. Now, the third characteristic, even though they are so strong, but they are short range forces. Okay, they are extremely short range forces. Okay, now they do have a range. The range is between 0.8 to around 10 Fermi. Suppose if two nuclei are more than 10 Fermi, then they are practical infinity. They are at practical infinity. But suppose if two nucleons are less than 0.8 Fermi, then the same nuclear attractive force is going to become extremely repulsive. It's going to push both the nucleons away. Okay, this is a very important characteristic of a nuclear force. The next property is that, see, these nuclear forces, they are saturated forces. Saturated in the sense what? If there is one nucleus here, it is going to attract only the immediate neighbor to it. It's not going to attract one nucleon, one proton here and one more proton here. No, it's not. That's not how it works. It's a saturated force. It's going to attract its immediate neighbor and not something else. So these are what we mean by saturated forces. Next one, they are non-central forces. Unlike gravitation or electrostatic force, they are non-central forces, right? And the last characteristic is they are spin dependent. Okay, spin dependent in the sense, see, every nucleon has a spin of its own. Okay, we say plus half, minus half. I mean, there are different ways of understanding the spin. But these nuclear forces, what we have, they depend on the spin of the nucleon. If two nucleons they have a parallel spin, their force of attraction is more. If they are anti-parallel, then their force of attraction is a little lesser. But they do depend on the spin of the nucleon. Okay, so this is another important characteristic of nuclear force. Now that you have understood what is a binding energy, what is binding energy per nucleon, and what are nuclear forces, in the next upcoming videos, you guys are going to learn more concepts about nucleus.